Hi, I'm Kent Dahlgren. In this video, we'll introduce you to some work we've been doing on the transmission of HD video over RapidIO links for sensor fusion applications.
PAN1 is the first in the series of sensor fusion application notes from Praesum. It demonstrates a transmission of 1080p video over 5 gigabit RapidIO links. The concepts in it can be applied to other streaming data formats, for example, JESD204, and it can also be extended to higher data rates, such as BRC3, which supports from 10 to 28 gigabit links. It uses the RapidIO Type 9 encapsulation as defined in the data streaming specification, which is an emerging standard for transport of sensor data in aerospace applications. The data streaming specification was originally targeted for transporting network traffic like Ethernet and TCP/IP across RapidIO links. The streaming sensor data use model uses a proper subset of the specification. It omits traffic management and simplifies the options. Data streaming eliminates the need for shared memory access between nodes. It simplifies security and eliminates the need for the coordination of address spaces. It's similar to Ethernet transport, but with RapidIO benefits. We'll talk more about this later. Type 9 encapsulation is defined in the data streaming specification and provides mechanisms to segment continuous data streams into start, end, continuation, and single segment packets, as shown in this figure. The policy for segmentation is user-defined. In PAN1, segmentation is done on a line-by-line basis on the video stream. The key benefits of using the RapidIO data streaming specification for the transport of sensor data include it is a reliable transport. This guarantees that error-free data is delivered across the link without processor intervention, unlike Ethernet, which is a datagram service. In addition, low-latency RapidIO links support multiple video streams multiplexed across the link efficiently, and it includes multicast support. The sensor data head does not require a processor. This saves power and eliminates the need to qualify another code image within the system. It's also scalable. We'll be having demos showing RapidIO 4K and 8K video transport using BRC3 links soon. The Praesum RapidIO streaming endpoint core is optimized for streaming data applications. The key interfaces include two Axi4 stream interfaces for transferring streaming data. There's a sync interface for outgoing streams and a source interface for incoming streams. In addition, there are two Axi-Lite interfaces. One is the local management interface, which is used by a local CPU if implemented. There's also what we call our application register interface, which is an Axi4 Lite master interface. This is used to connect local peripherals that can be managed remotely across the link, eliminating the need for a local CPU. The PAN1 demo transmits HD video from a pattern generator over the RapidIO link. It also receives an HD video stream from the link and displays it on an HDMI monitor. Adaptation shims on the source and sync interface perform the functions of segmentation and reassembly of video lines and data packing and unpacking. These shims are delivered as System Verilog source code and are intended to be a starting point for customer-specific designs. The demo operates standalone using a loopback. The demo shows the deployment of the design on a microchip, PolarFire FPGA, hosted on an Aero Everest development kit. In addition to this commercial device, the design is easily targeted to an RT PolarFire device for flight applications.
And here you can see the demo in action. The internal traffic generator generates a 1080p video stream, which is converted into RapidIO Type 9 packets, sent out across the SFP, looped back through a fiber loopback plug, comes back in, is converted back into video stream across an AXI streaming interface, convert it into HDMI video, and put up on the screen with this attractive Summer of Love Paisley Park pattern. We're not only using this demo for demo purposes as a standalone, but we're also using it for traffic generation for testing our sensor fusion hub, which will be highlighted in an upcoming video. Thanks for watching.